Please check your audio and video settings, please. Yeah, to save the time and to deliver maximum content in less time, I'm trying to use ready-made documents. I'm trying to use ready-made document, guys. Okay, this is also, I only prepared this document for previous batch. Today our module name is what? Spring AOP. AOP means what? Aspect-oriented programming. Everyone type what is AOP? Everyone type in the chat box. AOP means what? Aspect-oriented programming. Now listen carefully. Always remember, aspect means additional logics. Aspects means secondary logics. Okay, now let me explain what is primary logic, what is secondary logic. Yeah, that's good. Aspect-oriented programming. The logics in the application or project that are minimum and mandatory to complete the task are called primary logics. Without those logic, application is not there. Without those logics, a project is not there. Such logics are called as what? Primary logics, boss. Withdraw money, deposit money, transfer money, opening an account, closing an account, checking balance. These are mandatory logics in what? Banking application development or not? These are definitely mandatory logics in banking application development was. Super. The additional, optional, and configurable logic. What do you mean by configurable? Whenever we want, we can apply it. Whenever we want, we can remove them. Whenever we want, we can apply them. Whenever we can remove them. The additional, optional, and configurable logics of the application or project are called secondary logics. These logics are not minimum logics of application or project development. These are optional logic to place in the application development. When they are placed, our application becomes more perfect and accurate. Our application becomes more perfect and accurate, guys. See, guys, they are not minimum logics, they are not mandatory logic, but when they are applied, boss, our applications becomes more perfect and accurate, more stronger and accurate. Are you getting my point, guys? Understanding my statement? More perfect and accurate, more stronger and accurate. Is that clear, guys? Okay, listen, guys. We will say, this is my primary requirement. Getting software job is my primary task now. Okay, going to malls, enjoying life is secondary now. We will say primary and secondary. Okay, you are playing cricket very well, but you are also doing engineering. But you will say completing engineering, getting job is my primary goal. Okay, in that process, okay, playing cricket well, winning the matches, going to different levels is my what? Secondary priority. So in every project also, primary logics will be there, secondary logics will be there. Right now, boss? Primary logics will be there and secondary logics will be there. Are you getting my point there, guys? Super. Performance monitoring is the secondary logic. Logging, which keep track of the application flow, secondary logic. Auditing keeps track of user activities, secondary logic. Caching remembers the data, secondary logic, boss. Security protects the data is secondary logic. Without these things also projects can be there. But when these are there, our application become more perfect and more accurate, more stronger and more perfect. Same thing now, boss. See, I can conduct the online class without enabling chat option, without interacting with you people. But for that one, what are the minimum things required? Zoom required, faculty, students required, right? These are the minimum logics in the towards conducting the classes. But there are additional, optional, and configurable logics, boss. They are additional, optional, and configurable logics. We need to worry about those logics also now, boss. Come on. We need to worry about those logics also now. See, enabling chat box, taking queries from you, me answering, once in a while switching on mic of yours, okay, scolding you people, alerting you people, all these are secondary logics now, boss. So these secondary logics are helping me to conduct the primary logics called conducting classes more effectively now, boss. Conducting primary logics, running primary logics more effectively now, boss. Come on. Super, guys. Tell me, these secondary logics are technically called aspects or middleware services or middleware services or cross-cutting concerns. Aspects or middleware services or cross-cutting concerns. Super. Why they are called cross-cutting concern? You take banking project, Rabab. Service one, daily transaction service, loan module service, insurance service. These are three independent services now, boss. Okay. But how many times login logic will be written? One time. It will be applied on how many primary logics? 1, 2, 3. How many times auditing logic will be developed? One time. It will be applied on how many primary logic? 1, 2, 3. How many times caching logic will be developed? One time. It will be applied on how many primary logics? Multiple, right? So if you look at the arrows, they are cutting the primary logics seriously. That's why can we call them as cross-cutting concerns? That's why can we call them as cross-cutting concerns, boss? Can we call them cross-cutting concerns, boss? Array, listen. These are primary logic, primary logic, primary logic, primary logic. These are secondary logic. How many times they will be developed? One time, right? Come on. These are the concerns which are applied across the primary logics. Across the primary logic. So these are cross-cutting concerns. I hope you are understanding why they are called cross-cutting concerns. Are very simple, Rababu. In any project, primary logics are horizontals because they will be developed independently, running parallelly, executed parallelly, right? But secondary logics are verticals. They will be developed one time, but applied on multiple primary logics. If you put them in the form of arrows, secondary logics are cutting the primary logic to apply on multiple primary logics. That's why they are also called cross-cutting concern. Cross-cutting concern. Listen, in any project, the primary logics are horizontals. Multiple primary logics will be developed parallelly and horizontally. Secondary logics are called verticals because they are developed only once. They are developed once for entire project, but will be applied on multiple primary logics, nothing but horizontal, as cross-cutting concerns. As cross-cutting concern. Convinced you guys? Okay, now listen. You take a software company. Project 1 development, horizontal line. Project 2 development, horizontal line. Project 3 development, horizontal line. But you take accounts department, HR department, financial department, accounts department, financial services department, marketing department, HR department. They will be there parallelly for every project? No. For all projects, only one unit will be there, but that unit will be used by all the projects or not? That unit will be used by all the projects or not? Come on, try to visualize. In a software company, technical teams are, project teams are horizontals. HR team, financial services team, okay, accounts team, all these are verticals. All these are verticals. Are you getting my point, guys? These verticals will be created once, but will be applied on multiple horizontals. Similarly, these primary logics are multiple. They will be running parallelly. They will be running parallelly, but the verticals will be created only once and they will be applied on multiple horizontals. They will be applied on multiple horizontals. Got it, guys? Convinced, my dear? Secondary logics first. Secondary logics. Here is my primary logics. Primary logics 1, primary logics 2, primary logics 3. Primary logics 1, primary logics 2, primary logics 3. In any project, primary logics are horizontals, right? Secondary logics are verticals. Okay, they will be developed only once for entire project and will be applied on multiple primary logics as cross-cutting concerns. Super, boss. Now tell me now, boss. Sir, AOP, sounding like OOP? AOP is seriously sounding like OOP? OOP means what? Object-oriented programming. AOP means aspect-oriented programming. Is AOP is a replacement for OOP? Is AOP is the replacement for OOP? No. No. AOP is not replacement for OOP. In fact, AOP is built on the top of what? OOP. That means AOP internally uses what? OOP. AOP internally uses AOP. So overall conclusion is AOP complements OOP. AOP complements OOP. Are you getting my point, guys? AOP, aspect-oriented program. OOP, object-oriented program. Are you getting my point there, guys? Come on. AOP, aspect-oriented program. OOP, object-oriented program. AOP is extension of OOP. Sir, already we are happy with OOP style programming. Na? Why should I learn AOP? This question hits your brain, na, boss? In everyone's brain, this question hits or not? We are happy with Okay, now listen. Try to understand problem that is there with the OOP style program. Problem with OOP style program. In the business methods of service classes, we are forced to mix up both primary and secondary logics in OOP style programming. As part of OOP style programming, we try to mix up primary and secondary logics or not. Have a look, guys. Public class bank service, withdraw method, deposit method. This is business method 1, business method 2. Here logging logic, which keep track of application flow. Auditing logic, which keeps track of what various activities of the user. Listen, the difference between logging and auditing is logging keeps track of applications code flow. Whereas logging keeps track of applications code flow. Whereas auditing keeps track of what is there, guys? Whereas the auditing keeps track of. Whereas the auditing keeps track of. Whereas the auditing keeps track of. Tell me. Okay, user activities in the application. Activities in the applications execution. User activities in the applications execution. User activities in the applications execution. Comfortable, my dear? Got the clarity, guys? User activities in the applications execution. This is my withdraw, guys. This is my deposit. Logging logic, auditing logic, security logic. Balance is equal to balance minus amount. Return. See, guys, here, this is primary logic, balance. These are secondary logics, right now, boss? These are secondary logics. But both are mixed up now. I'm writing just a dot. Technically, they are also Java statements, right? These are the secondary logics. Tell me, guys, we are mixing up both primary and secondary logics here now, boss. We are seriously mixing up both primary and secondary logics here. What do you say, boss? That's happening or not? Technically, definitely it's happening or not? Come on, boss. See, since we are mixing up primary and secondary logic, code becomes clumsy, na, boss? Code becomes very, very clumsy. If I try to modify any primary or secondary logic, other logics will be disturbed now, boss. Super. Okay, now listen. Someone said that security is not required while deposit. Because who will deposit money to wrong accounts? Security is not required. I want to disable it. I have to disturb the source code. I want to enable again. I have to disturb the source code. Central government notice. Why are you suffering customers, Babu? Why people will deposit money in your account unnecessary? Hey, disable security identity verification while depositing funds to accounts. Okay, disabled. But later they notice terrorist organizations depositing money into what? Poor people's accounts, poor youngsters' account, and later they are misguided or diverted towards what? They are misguided towards terrorism. So central government noticed that. Then they said, okay, every deposit must be kept tracked. Every deposit operation must be kept tracked. Again, security is required now, boss. Central government is said that not required. Central government is saying that required. Central government only saying that not required. Same central government is saying that required. It's really, really meaningless or not, boss? It's really, really meaningless or not? I want reply, boss. So there are some limitations in OOP style programming. That's what I'm trying to say. Limitations of OOP style programming, boss. The primary logics and secondary logics are mixed up in every business method. The method that contains business logic is called business method. Business logic is nothing but primary logics. Business logics or service logics are called primary logics. The method that contains business logic is called business method or service. Super. Tell me, limitations of OOP style programming. The primary and secondary logics are mixed up in every business method. That means there is clean separation. There is no clean separation between logics. There is no clean separation between logics now. Clear, my dear? Super. We are writing same secondary logics in multiple business methods of multiple service classes. So we can say there is no reusability for secondary logics. There is no reusability for secondary logics. Understanding my statement, guys? Are you getting my point there, guys? Come on, are you with me? There is no reusability. See, guys, year logging, year auditing, year security. Come on. Reusability is missing now, boss. Next. While enabling or disabling secondary logics on primary logics, we need to modify the source code of business method, which is complex process. Okay, which is complex process. So indirectly we can say tight coupling is enabled between primary and secondary logics. Tight coupling between primary and secondary logics. It is not industry's standard process. It is not industry's standard process. What do you say, boss? Is it industry's standard process, guys? Is it industry's standard process, guys? Unfortunately, it is not industry's standard process. Unfortunately, it is not industry's standard process. Nice. In the industry, it is not recommended. It is not at all recommended, guys. Okay. Code in the business method looks very clumsy. Very clumsy because we are mixing up both primary and secondary logics. We are mixing up both primary and secondary logics. Got the clarity, boss? Come on. Are you understanding my statement, boss? Solution using AOP style programming. Yes, for this problem, there is a solution. What AOP says, you know? AOP style programming says separate secondary logic from primary logics, but secondary logics will be but apply secondary logics with primary logics dynamically at runtime. Dynamically at runtime by generating in-memory proxy class. The temporarily generated class at runtime dynamically where primary and secondary logics will be mixed up. Understanding indirectly modularity was indirectly modularity understanding. AOP style programming says separate primary and secondary logics during development. During development. During development, but apply secondary logics with primary logics dynamically at runtime. Dynamically at runtime by generating in-memory proxy class. Okay. What is the temporarily generated class? Proxy. Array, listen. In your college days, you might have given proxy attendance. Your friend is absent, but you want to give his attendance. You will say SR for your friend number or not. Your friend is feeling very tough to write certain exam. In your place, you sent your friend to write that exam, right? In your place, you sent your friend to write that exam. Understanding my statement? Say guys, you will write exam. You will write exam on behalf of your friend. That day you are acting proxy for him. Is it forever only temporary? Temporary. Proxy class also, the class that is created dynamically. This is very interesting, Rababu. So far you created a class, you saved a class. But runtime one class is generated, right? Runtime class is generated. In that class, both primary and secondary logics will be mixed up. That class is called proxy class. Why it is called in-memory proxy class? But that class is not saved in hard disk, guys. That class is generated dynamically in the memory where application runs. Nothing but in the JVM memory where application is running. Okay, that's why that is called in-memory proxy class. In-memory proxy class. This class is created at runtime. This class is not there at compile time. This class is purely created at runtime, boss. Everyone getting my point? By generating in-memory proxy class. Have a look, have a look. Main class or target class, guys. Primary, only primary logics are there. Check it out. Only primary logics. Only primary logic. Are you listening? Are you concentrating, boss? Okay, now listen. For login, separate class. For caching, separate class. For security, separate class. Only having secondary logic, separate classes, boss. Having secondary logic, separate. Okay. At the time of development, secondary logics are separated from primary logics or not? Secondary logics are seriously separated from primary logics. Super. Okay, now these primary and secondary logics are given to AOP enabled software. Lot of examples are there for AOP enabled softwares, guys. Spring AOP, Axpex AOP, JBoss AOP. These are AOP enabled software. And this AOP enabled software will be controlled using XML configurations or annotation configuration. Controlled using XML configurations or annotation configurations. Controlled using XML or annotation configuration. What this AOP enabled software will do, you know, generates one in-memory proxy class where for in-memory proxy class, source code generation, compilation, and execution takes place in the JVM memory of the application. Where source code is generated? JVM memory. Where compilation happens? JVM memory. Where execution takes place? JVM memory. Where application is running, in that memory only this one. In that memory only this will happen. There, one proxy class is generated. This is proxy class, guys. Dynamically generated proxy class extending from our target class. Our target class. Our target or main class. Dynamically generated proxy class. Dynamically generated proxy class. Superna boss, got it? Tell me, in withdraw method, primary and secondary logics. Primary and secondary logics. That means these three logics, guys, plus primary logics. Again, these three logics, guys, then primary. Okay, now tell me, mixing is happening at what time, guys? Runtime. What's the advantage, sir? What's the advantage? Execution one. Execution one. Through XML file, I said, on withdraw method, all the three secondary logics, deposit method, all three secondary logic. Dynamically, one in-memory proxy class is created. In that one, both primary and secondary logics are mixed. In that one, both primary and secondary logics are mixed up. Got it, guys? Both primary and secondary logics are mixed up. Guys. Everyone getting my point? Both primary and secondary logics are mixed up, guys. Convinced, my dear? Okay, now listen. I stopped the execution. In XML file or annotation, I said on withdraws, security is not required. Deposit, all three logic. Withdraw, only two logic. Freshly, one more in-memory proxy class will be generated, where withdraw method will be what? 2 secondary logic, 1 primary logic. And deposit method with what? 3 secondary logic and 1 primary logic. Are you understanding my statement, guys? So that means this will be generated dynamically in a boss. Very much dynamically it will be generated. And it can be controlled as needed or not. Because this is dynamically generated class. Through XML, I can give instructions to AOP how to generate and where to generate, having what it should be generated. So that means we have a control on applying secondary logics on primary logics, na boss? Super. The AOP enabled software dynamically creates in-memory proxy class, having both primary and secondary logics in business method, as guided to AOP enabled software in XML configurations or annotation configuration. So this plays major issue, boss. 10 times you run this application, 10 in-memory classes will be generated. 20 times you execute this application, 20 in-memory classes will be created. 20 in-memory classes will be created. Convinced, my boys? At the time of development, they are not mixed up. At the time of execution, they are mixed up. Okay, boss. Now listen. Advantages of AOP style programming. What are the advantages, guys? Here, primary and secondary logics are not mixed up. So, there is clean separation between logics. Clean separation between logics. Since secondary logics are separated from primary logics, we can say secondary logics are reusable logic. How many times secondary logics are developed, guys? One time. But how many places we can apply, guys? Multiple places. That means they are reusable logics or not, boss? Are you understanding my statement? After completing execution, in-memory proxy class will be deleted automatically. Using XML or annotation configuration, we can enable or disable secondary logics from primary logic without disturbing the source code. This is another advantage, na boss. Whenever I want, I can apply. Whenever I want, I can deploy, remove by using XML or annotation configuration. It is industry standard approach to develop the application. Industry standard approach to develop the application. Allows us to have loose coupling between secondary logics and primary logics. Allows us to have loose coupling between secondary. This is target class, nothing but main class, where primary logics are there. These are aspects, guys. Aspect 1, aspect 2, aspect 3, where secondary logics are there. Aspect 1, aspect 2, aspect 3, where secondary logics are there. Here, primary logics are there. Super na, boss? Yeah, this is AOP enabled software. It internally uses CZlib code generation libraries or JDK libraries to generate the in-memory proxy classes dynamically. In the generated in-memory proxy class, guys, it contains both primary and secondary. Internally, which is the extension of Biswadit Sahu, this class generation, compilation, execution happening at what time, guys? Runtime, right? Whenever you run the Java application, every time JVM memory, every time heap memory creation, every time object creation, in that process, class generation, class code compilation. What is there? Which is extension of OOP style programming. Without OOP, there is no AOP. Without OOP, there is no AOP. Now listen. Okay. Simply how I can remember, sir. You can remember OOP style programming is like taking tea from a normal hotel. Chai from normal hotel. You go to hotel, you order the tea. What he will do, guys? He will give tea having all things together. What things? Milk, decoction. These are the primary logics. Okay. Sugar, secondary logic. Ilachi powder, secondary logic. Ginger paste, secondary logics. But he will give all things together or not? He will give all things together. The way we drink chai, tea in regular hotel, normal hotel, is like OOP style programming. When you order tea, according to his popularity, he will give tea with all added flavors. He will give tea with all added flavors. Right, boss? He will give tea with all added flavors. What do you say, my dear? Convinced or not? I hope you are convinced. Come on. Super. You have gone to 5-star hotel, boss. You have gone to 5-star hotel. You have ordered tea. He charges 600 or 700 rupees for tea, boss. But observe very carefully. He will bring milk kettle separately, decoction kettle separately. Yes, na? Okay. Sugar crystal separately, ilachi powder separately, ginger paste separately. Okay. You are a diabetic. You will stop using sugar. You don't like ilachi powder. You have allergy for that. You will stop using that. And you can mix milk, decoction, everything as per your comfort, na boss. Deliver independently. Before drinking, customer will mix up and will prepare the tea and will take the tea. Come on, guys. So, AOP style programming is looking like 5-star hotel tea or not? AOP style programming is looking like 5-star hotel tea or not? Deliver independently, mix everything before consuming. Before consuming, right now, boss? Super, guys. OOP style programming is like tea from regular hotel, where what is that? Milk, decoction, primary logics are mixed up with come on, guys, mixed up with what is that? Sugar, ilachi powder. Next what, guys? Ginger paste. Paste kind of secondary logics while delivering the tea itself. While delivering the tea itself. AOP style programming is like tea from 5-star hotel, guys. P from 5-star hotel, where milk decoction, milk decoction and okay, milk decoction, sugar, elachi powder, ginger paste, kind of secondary logics will be delivered separately, to the customer. But the customer will mix them before drinking as needed. Okay, guys, I think with this one example, you got maximum clarity, my dear. With this one example, you got maximum clarity. So far, we are enjoying what? OOP style programming, where primary and secondary logics are mixed. Okay. Now, listen. I have kept some points on this also. Normal Java class, guys. .java, it is there in file system, especially in hard disk about HDD. Super. Dot class file is also there in HDD. Also there in HDD compilation. JVM goes for execution of dot class file. Execution of dot class file in the JVM memory. In the JVM memory of the RAM. In the JVM memory of the RAM. In the JVM memory of the RAM was. Cool. In the JVM memory of the RAM. So where this will happen, guys? Okay. In JVM memory. This will happen in JVM. Okay, guys. Look at in-memory proxy class, guys. When it comes to in-memory. Application or project execution, JVM. Source code generation. Generation of source code. Got it, guys? Generation of source code. Byte code, and execution of byte code. Everything happens where, guys? Runtime class generation, compilation, execution takes place in the JVM memory where the application or project runs. So it is called dynamically generated proxy class. Dynamically generated proxy class. I hope you understood the difference between normal Java class and in-memory proxy class, guys. Why it is called in-memory? It is generated in the memory where application is running. What is that memory? JVM memory of the RAM. Since the proxy class is generated in the memory where the application is generated. Nothing but the JVM memory of the RAM. Nothing but JVM memory of the RAM. Got it, guys? Nothing but JVM memory of the RAM. Got it, guys? Understanding my statement? I hope you got crystal clear clarity about AOP. Theoretically, coding wise, I will take care. Don't worry. This diagram speaks a lot. This diagram speak. Primary logic separately, secondary logic separately. We give them to AOP enabled software. Like Spring AOP is one AOP enabled software. Axpex AOP. Another AOP enabled software, guys, that internally uses CZ or JDK libraries to generate the in-memory proxy classes like this. To generate the in-memory proxy classes like this. Everyone enjoyed, guys? You got somewhat idea about AOP enabled software? What do you say? What AOP enabled software says? Or what AOP says? Don't mix up primary and secondary logics in the business method. Write only primary logics in the business method. Write